Wayne, one other thing. Actually, clouds are formed from updrafts. So the wind is caused, obviously, when hot air rises and cold air comes and takes its place. But when the hot air is rising, it's lifting water droplets up.
Right.
That's where clouds come from. But the weight loss is very intriguing still.
Yeah. So there's a water cycle, right? So the water vaporizes and rises. The droplets are very small and they rise, and then as air rises into the atmosphere, it cools, and as it cools, it condenses. So, yeah.
Falls and we have rain, and then we grow.
But I just found it interesting that the droplets don't always fall, the way we would think that they would fall. So I might be wrong. I'm probably wrong, but it's a thought.
Sorry, what city are you located in?
Me?
Yeah.
I'm on the West Coast.
Oh, okay.
Vancouver Island.
Yeah. We wanted to get in touch with the Triumph Lab over there, but the cyclotron place. But,
is that in Nelson, BC? Vancouver?
Yeah, some place in Vancouver, but they're pretty busy, so they're hard to get in touch with.
I'd imagine.
Yeah.
I don't know if they listen to ordinary people that are not like renowned scientists or universities.
I mean, they replied to us. They're just a little bit slow. Yeah, but it doesn't matter. We had a plan B. Yeah.
One other interesting thing about water is when you sweat and the water evaporates, the reason why it's cooling you off is because heat is really a nuclear motion that is being experienced on a much larger level, on a macroscopic level. So there are atoms of the water molecules in your sweat that are moving faster than the others. Those are the ones that get released first into form and evaporate, leaving only the cooler ones behind. That's why sweating cools you off, and that's why swamp coolers work. Process of evaporative cooling. Anyways, moving over to what the lab has going on over here. We are back in Bismuth. We managed to make some vapor deposits of bismuth on a ceramic disc over here. This is actually a thin film of bismuth vapor deposited on either side of a ceramic disc. And I tried doing it using the freezing method. That didn't work. It turns out that you just have to clean the machine each time, and it worked out pretty well. You're able to see a little spot over here. It was slightly dirty, so the bismuth only likes to connect where it's perfectly clean. Another variation that we managed to create is aluminum. We'll be running this later in the Alzofon experiment. This is just pure aluminum on a ceramic disc. See, I'm wearing gloves to keep everything nice and clean. We're trying to make the oxide layers. This is what we spent a lot of time on last week, making various methods of heat combined with oxygen to try to get a nice oxide layer. So this is what the heat and oxygen method gave us. Lots of bubbles on the surface. And it didn't create a very nice oxide layer, actually. I think what we're going to end up having to do is some sort of electrolysis system, anodizing it, which should work pretty well. The latest sample that I've made is actually bismuth on bottom with aluminum on top of it. So this is two different metals mixed together. We were going to go for the full arts parts experiment today. We would have had it ready by now, but before turning the machine on, I did a little safety check and realized that magnesium, hot magnesium, if exposed to atmosphere, will burn. And anything you spray at it other than a Class D fire extinguisher will just make the fire worse, and it could possibly destroy our vapor deposition machine, with a fire that we can't put out. So we're going to wait for that Class D fire extinguisher to arrive. Costs $900. Those things are very expensive to deal with magnesium or aluminum fires. So that's what's happening next with our vapor deposition thing. It should be here next week, so we'll be able to get a move on that. Behind me over here, you can see the Podklenov impulse chamber. The bottom part is clear acrylic. It's just covered with a nice sheet of, I think it's like cardboard or something like that, that it comes with a nice little film to protect it until you're ready to use it. I didn't take that off yet because we do have some machining work for it. On the floor is the Helmholtz coil that is 26 inches in diameter. We actually made 3 of them. The first one didn't come out so nice, but the second 2 did come out. So they will be positioned roughly like this. And I'll be powering them with a large hybrid battery from the hybrid battery shop that we have over here as well. Keep their the current equal on each of them, and keep the field as homogeneous as possible. We need a pretty high voltage in order to pump these coils, probably about 250 to 300 volts DC, and they're going to be pulling about 20 amps each, 18.5 gauge wire. That's what's going on with that experiment. The Magnon experiment that we were working on last week, after the conference, I finally got the mechanism going. It does work right now. You can turn it on. The idea was to, oh, it's not plugged in, but this would spin, and there's a little bearing on the side of it. And the idea was the bearing would create a short circuit for the magnetic field. So the magnetic field peak strength would be going around in a circle inside of the ferrite and hopefully create a magnon, which is a rotating magnetic field inside of the material. The issue was that the motor is not strong enough for that, and all that happened is it seized up as soon as the magnetic field was applied. There may be a more solid state way of achieving the same effect. Aidan Schaffer, I think, is looking into that right now. But that's where that experiment is sitting at the moment. And that's pretty much what we have going on right now. I saw, Todd, you mentioned something about the Woodward effect in water. What was that about? Todd DeCiato, are you there? Able to talk?
Yeah, I was mass variations. He was talking about it changing mass as it moved back and forth from one side to the other. It's the Woodward effect.
Oh, between different phases, yes, just like electrical energy going from capacitive to inductive.
Yeah, but yeah, Wayne was talking about the phases of ice and changing mass and moving back and forth, creating a thrust. And I'm like, that's the Woodward effect. So that's all.
My concern with that experiment was that the temperature was relative to the ambient temperature, which would change the amount of condensation that builds up on the surface of what he had there. And you can even see in his frozen sample that there was condensation outside of the chamber, adding weight to it. And when you heat it up, it removes that extra condensation.
I didn't catch that. Good. But I thought Wayne did a great job.
Yeah, definitely. I loved his presentation. I wish my presentations looked all like that.
Thanks, guys. I'm sleep deprived and I sort of won it. So
It's okay. I'm sick as hell too. So
I'm glad you enjoyed it, at least. I just
Yes,
sent the
good.
link to Tim. Hopefully he can get the slides out to you.
Okay, does anyone else have any questions, any comments? I guess we can go to open discussion at this point, or, oh, Pepe, how are you?
Very good, Mark. No, I just wanna tell Hera, the one who presented, was really good. Okay, this is the first time I actually in the front of my seat, just looking at what you had to say and what you did. Thank you very much. Okay, I appreciate it for your work and I appreciate that you're sharing it. Good.
Thank you. I appreciate you the compliment. It means a lot. And glad to be inspirational, I hope. Okay.
Yeah, yeah. Well, it's good thing that you're telling us what you did. So whenever we do something different, and if we know something already doesn't work, well, we don't do it. So thank you. That's very good help, and I'm sure I will share with you whatever I have.
Okay.
Thanks.
Cool. Thank you.
You're welcome. Thank you.
Pepe, you mentioned you have some ideas for how to try Alzofon.
Well, I have some ideas. You want me to show him right now?
Sure. I mean, I guess we're in open discussion right now. It doesn't look like anyone's fighting for the mic.
Okay, let me.
I just want to say that that bismuth thing there looks really spectacular.
Thank you. Thank you. Yes, we're back in bismuth.
Really specular.
Well, one thing I learned about bismuth, which is very interesting, is that it is magneto-resistive. It's one of the most magneto-resistive materials, meaning that if you apply magnetic field to it, its resistance changes. The reason why it's not being used as a Hall effect in place of Hall effect sensors for Gauss reading is because the thickness of the thickness and the homogeny of the crystal changes that parameter so much that it's hard to make reliable sensors. You can shake the sensor, you know, and something happens like a fracture line crack inside of it. Suddenly your number's way off. But theoretically, you can make a very accurate Gauss meter using thin film bismuth.
Hey, Mark, when you do your experiment for the Alzofon, with those discs, what percent have you predicted? What kind of percentage in weight loss are you expecting to produce according to, you know, to the input of the energy, the frequency?
I try not to make any predictions. I just look at what the scale says and go with that.
No, okay.
I'm not really about the theory about, you know, what can I do different in the lab to see the effect. I can only rely on what it shows me and not, you know, I hope to see 100% weight loss.
Oh,
Fingers
okay.
crossed.
Yeah. Well, good
The
luck.
most
I hope
we've
you
seen-
get good result, because if you do, that means you have invented solid state propulsion, and that will make everything obsolete.
Yeah, I mean, it will take a while for everything to become obsolete, but yes, it will change the world as we know it. The most we've seen was in the range of about, I think it was about 15% weight loss. We had the magnet in a different orientation in that experiment where the field lines were going vertical. Right now, our experiment has them going horizontal. So I don't know if that has any effect on the experiment.
Will you be doing, you know, any experiment, let's say when the discs are like between, let's say 45-degree inclination between horizontal and vertical, or 30-degree or 60-degree, to get, you know, some measure of performance?
There was a suggestion to point the magnetic field toward true north, meaning toward the star Polaris. Amy Estridge, the girl who recently passed away, actually made that recommendation based off her dad's theory. The issue we're having is that our electromagnet weighs about a ton, and it's in a very confined space. So shifting it into that position is quite difficult.
That's true. Well, the piece itself, you can keep it, if you incline one of those discs at an angle, you don't have to turn the magnet, at any angle, because
Oh,
the
no,
magnetic
the
field
magnetic
would be.
field. No, the magnetic field needs to be in that angle, not the sample needs to just fit in wherever the magnetic field is. The magnetic field is what matters.
Okay, thank you.
You're welcome.
Yeah, I found there was it almost seemed like the movement happened in line with the RF. So whatever the RF vector was, I saw the sample move like it was repelled away from the antenna, let's say, or the direction in which the RF was going. That's what I saw.
Yeah, that's interesting.
I think you saw the same thing. So it's like one of those, right angle things, right? Like the movement that you saw.
Also, keep in mind that you were dealing with an antenna. I was dealing with a horn antenna, which are different. You're dealing with a dipole antenna versus a horn antenna. So I guess you have more control over it when it's just a dipole antenna.
I don't know. I think the horn antenna is pretty directional though. Like the horn or the Yagi Uda antenna, you get a directional.
Oh, Yagi is very directional. Yeah.
Yeah, you get a directional vector, right? So, and then if your magnetic field is horizontal, then you get, you might see some weight loss or something, or weight gain, just depending on the direction of these vectors.
I'm trying to get some weight loss over here too.
But I don't know if it's weight. I'm not saying it's like, I don't think it's like weight loss, like anti-gravity. I think it's like a directional kind of force, like a propulsion, something more of that nature. That's kind of what I see. Yeah.
The best effects I've always seen were with thin film materials. So that's where we're trying to push the research. That's where we got the vapor deposition machine and all these samples. And hopefully this week we'll be running experiments nonstop with various setups. And when the fire extinguisher comes, I'll be able to start playing with magnesium safely. Pepe, so what were you going to show us?
Well, is that okay if I share my screen?
Yes, go ahead.
All right. Just hold on, let me get ready. Do you see this? It's
No.
a file, a PDF file.
Oh, yes, we see it now.
Okay. Well, this is the file I was saying to you before, and these are the changes that I suggest. Okay. The main change is the cover. Okay. I believe the cover should be made out of aluminum. If I am to make the experiment, this is how I will do it. Okay. I will use aluminum 6463. I melt it, and then I put iron filings. I put 10% by weight of iron filings. And after that, I put a film made out of gadolinium, cerium, calcium, and zinc with these percentages: 28, 14.7, 47.1, and 8.8. Okay. And the reason why is because of this. Hold on. I think I had things all over the place. I just have to put it together. Okay. There are two main reasons why I choose these elements. Okay. The first one was Mr. Wade parts. I'm not sure if you guys heard about Mr. Wade.
Mr. Waite,
Yeah, Chuck Wade. This Chuck Wade found some parts of in San Agustin in New Mexico. He claims that those parts were collected from the, from the UFOs from 1997. And he did several lab tests, and this is what he came up with, these parts with these percentages. Okay, so I'm just trying to replicate what he found. Yeah, you can Google Mr. Wade. That's why I'm getting these percentages. And also I'm getting this material because of what Alzofon says. He mentions that 10% had to be iron. The iron is gonna allow the magnetic field to go inside the cover made out of aluminum. And that's gonna point the nuclei easier to the right direction. That's why I'm suggesting this, okay? Another reason why.
Alzofon actually suggested a lot less iron, but that's interesting that you are recommending 10%.
Well, he said 10%, right?
No, I think he said about 0.5%.
Oh, well, let me, I think I have the Alzofon here.
I'm not sure if it's in the paper itself. I think it's in the book. I'm talking to David.
Okay, well, I look for it, but I'm sure it's about 10% what I saw.
Well, it does kind of make sense. The best results we've had were with a thin film, and we put some ferro fluid on top of it. At that point, it started to actually attract to the magnet, so you had to find a sweet spot where it wouldn't attract.
Exactly. Yeah. Well, I'll look for it later. I don't remember exactly what I saw, but I'll saw it there. The other thing I wanted to do with the Alzofon experiment is to rotate, okay? I did something like this to be able to rotate. This is just an structure. You can mount a motor, and you have a long shaft to rotate the sample piece. This is how the sample piece is. That's how I will do it. Let me make it bigger. What you see here is a cover on top. This is the structure to hold the cover to be able to mount on the shaft right here. But this thing, I couldn't make a better drawing in SolidWorks, but this is like a coil with similar to the Joule teeth circuit. The reason I'm using this is because we have to magnetize the cover, and at the same time, we need to extract energy out of it. So the coil has actually two wires, okay? One is used to magnetize, and the other one is used to obtain energy out of it, okay? And that's what's gonna help with the direction of the nuclei, okay? The nuclei has to move back and forth all the time. And I believe if we're able to do this back and forth, we're gonna be able to get some weight lost. This is another view. Maybe it should be on top, on the bottom. But before we go into this, we have to get the cover ready, okay? Without the proper properties of the cover, I don't think it's worth making the rest, okay? And that cover can be done by making a little piece. Well, let me stop sharing now. Okay, where do I stop sharing?
There we go.
Okay, thanks. Okay. One of the things that I saw in Mr. Wade parts, he had like 1 inch by 1 inch parts. And one of the interesting things was that he put a magnet close to the piece and the piece started like jumping. Okay. He wasn't really attracted to the magnet or he wasn't repelled to the magnet. He just started jumping. So with the CDM chemical vapor deposition machine, maybe we can, or you can do it. Do this combination that I already told you with the layer and see if when you put a magnet close to it, it starts jumping. Okay, once that's done, once we have that equilibrium of metals on different materials, then it's worth to make a bigger one and make the whole experiment.
I don't know about vapor depositing calcium.
Yeah, okay, yeah, that was when I first thought about it and I talked to someone that had the chemical vapor deposition, that was what he said, that it's not easy to do. I wouldn't know either how to do it. I didn't think about it because I don't have the machine or the money, but I look again into that, the calcium. And I'm
Calcium
not
even a metal?
Hmm?
Is calcium even a metal?
No, I don't think so. I don't know. That's a good question.
Oh yeah, it is metal.
It is?
Yeah. It's extremely, I guess you can. It's, you get pure calcium.
Maybe Aidan knows how to do it.
I would have to get some calcium, but yeah, it probably can be done. The boiling temperature is pretty low. It corrodes extremely quickly. It's an alkaline metal, so it'll combine with oxygen.
Okay.
Maybe what we could do is put the calcium into the machine and have the layer that goes on top of it vapor deposited immediately after inside the same vacuum. So I have two heating.
Yeah, that's another way to do it. Yeah, that's a good.
Yeah, but the temperature wise, it can work. As long as it doesn't react with tungsten. Yeah, you can buy calcium metal. Okay, it'll react with water at room temperature as well. That'll be pretty interesting to vapor deposit calcium. Any idea why you need that specific mix of elements?
Well, the main one is because of the report by Mr. Wade.
Can we get a
but yeah, the scientific proof. Well, the cerium and the gadolinium. Well, the gadolinium is paramagnetic, so I believe the paramagnetic properties is what makes it interesting. The chromium, I think, it kind of helps the paramagnetic properties to propagate better within the aluminum sheet. And other than that, I don't know why. I believe the other ones are just because it's easier to work with the material, or that was the material available. I imagine that. I would suppose.
Calcium reacts violently with water. Yeah, we could do this. Gonna be interesting. Very, very interesting. So you said we needed calcium. What other metals do we need?
Okay, let me go back. It's calcium, cerium, gadolinium, and zinc.
Well, zinc we have. I think we'll reach out after the conference and talk more about this concept. Can
Okay.
you send a link to the, put a link in the chat for Mr. Wade's sample, if you have any article about it?
Okay, let me, yeah, it was on his website. Let me look for it.
Oh, Shmuel S. said something about it. So Chuck Wade found UFO fragments, had this composition of elements.
Okay.
I think we have gadolinium here.
Actually, I have a copy of one of his reports. Maybe I can send it to you too.
Mhm.
Okay, I sent the file over the chat. And I'm gonna look for the link. Jeremy Ruiz, are you there?
Yeah, I'm here, man.
How are the kids?
Good, man. Yeah, I'm here. I got it.
Yeah, I think we're gonna get ready to wrap this up soon.
Wrap it up soon.
Oh my God, you got a dark light party going on there?
Well, I bought the kids a bunch of lightsaber swords, and they're playing lightsabers. So I turned the lights on. So we can see 'em. Let me
Oh, that's what it is.
well, let me see if we can.
You got Star Wars going on over there.
Come on, let's go. Yeah, let's try this out. Yeah, there you go.
So I just put the link to my presentation in the chat.
Go over there. Go get him, Nico.
Anybody streaming right now?
Yeah, I'm about to end the stream right now.
Oh, okay. I'm going to put my presentation on my YouTube channel with the explanation. And the link is also here in the chat.
Give me that. Yeah, these are cool lightsabers, totally. Well, I'm going to end the stream. Thank you all for watching. And thanks for everyone that helped out today. You guys are awesome.
Bye, YouTube.
Let me see if I can't close that and get my camera working on here now. Or do I have to restart my video? Oh, there we go. You guys see me now?
Yes, I do see you.
Hey, Jeremiah, I heard your website is going down, but I think
Get it up.
the efforts over the years were awesome, and if we can contribute, I will. So just let me know.
I got a guy. I'm gonna get him working on it. I gotta talk to him, and we're gonna put basically. I want to get some more. I want to build a new website, which is. I got so much content. I want to make like the best of the best available to like certain things. I don't know.
Yeah, you should check out EDC Soft for the web hosting. It's like $2 a month or something like that, and you get a lot of space. I can't send you the link. I posted it before, but I can't send it again.
Yeah, I got I'm trying Bluehost out, and but I gotta put a website together. It's gonna happen, but I've been just working like crazy hours, and I wrapped up 2 big jobs, and then I got a couple other ones, and I quit on another guy because it was just like too much.
Yeah, I hear you. I had 3 jobs earlier. Now I'm down to 2. So, yeah, if you need a PHP developer or like a backend developer, just let me know. So yeah, sorry, I feel a little bit dizzy because we had a great show yesterday here in Montreal. So I couldn't ask intelligent questions today, but yeah, thanks again, guys, for the great presentation. It was awesome, and I'll see you guys in 2 weeks.
Cool.
Sounds good.
Take it easy.
Thank
Catch
you.
you later.
I gotta get some more. I'm hopefully getting Jim Wood. I saw the first presentation. I'm hopefully trying to get Jim Woodward and Hal Fern on for an interview at some point. We'll see if that.
Oh, that would be sweet.
Yeah, that'd be cool, huh?
Jeremy, have you ever heard of this Wade sample? This guy from New Mexico found a couple pieces of apparently from a crashed UFO, and there's this whole analysis that Pepe just sent me of the metals, looking at it from microscope and different tests they ran on it.
Yeah, send that to me in the chat if you don't mind. I'd love to check that out.
Pepe, can you send it to Jeremy or just post it in the open group? This is very interesting. I'm reading it. I don't see any samples that have high concentrations of calcium. They have tiny bits of it. It's mostly aluminum and iron. There it is. Yeah. Download that that article. It's really, really interesting. I'm looking it over right now. Aluminum, iron. I mean, from these samples, it looks like I'm not putting enough iron in my sample. And I'm like having a light bulb moment right now, because I recognize that I did have very good results when there was more iron in the form of a in the form of that ferrous fluid, the ferrofluid that I used. Jeremy, I might be coming up to Massachusetts to see what's his name, to see Michael's lab.
Oh yeah.
Maybe we could stop by you afterwards. I saw it's pretty close by.
I gotta get a hold of Michael. We gotta go. Oh, we're gonna go to. That's right, July. It's July now. I gotta make sure I don't miss the MIT flea market.
When is that?
I have to double check and see.
Hit me up when you find out when it is. I might drive up there to check that out as well.
Yeah, that would be a good time to come up.
Hey, Nico.
Hi.
You remember the water park?
We went there before, and you know,
Who did we go to the water park with? We went with Mark and Mark's son. Remember?
And you remember Pinky? Nico, you remember Pinky?
Yeah, I remember him.
Is that
Did
Pinky?
Pinky lick your face?
Yeah, I went there before. I went there before.
You went to that place?
Yeah, and I petted that doggy.
You petted that doggy?
Mhm.
You like that dog?
He did not bite me or nothing.
No, she's a nice dog. She doesn't bite or nothing.
Maybe you come down again. We could go do indoor skiing at the ball.
Oh yeah. Oh, I seen that.
It's $40 a ticket. That's it.
Jeez.
$40 a ticket to go for 2 hours skiing.
Max.
Massive.
He wants to say hi too.
Hi. Hi.
What's the baby's name
Dog.
again?
Max.
Hey, Max.
Max eats a ton of food.
Max.
$200 of groceries a week. My kids eat.
That's all?
I eat all of it.
That. Well,
So, I eat all of the food.
You
Yeah.
have lots of spaghetti?
Food. I love food.
you like food?
I love food. I love food. No toad. Toad.
Food's good.
No
Food is
toad.
good.
Check Wade UFO website expired.
Joe is telling people he's going to build a flying car. He talked about anti-gravity. Maxis.
No joke. I went flying on Friday with the paramotor, at the beach, and a couple buddies came as well, and a guy landed near the surf, and his wing got caught in the waves. He got pulled out into the ocean. I had to jump into the water and help him cut his kite free so he can get out.
Wow.
Yeah, that was really scary. He almost drowned.
Yeah, I could see that.
Yeah, luckily I had that pocket knife with me. Nico, you want to come back and pet the dog again?
Pet doggy. Pet
You want
doggy.
to pet that doggy? That doggy? The cat's hiding out. He like goes on vacation when the kids come here. He like nowhere to be found.
And it's a woman.
The cat's name's Roman.
He always makes a one outside. Outside.
You guys want to go do some of these?
Yeah. It's fun. Here's anyone.
Chinese lantern.
Oh no.
I got the lanterns. You want to
Are
go
we
do
gonna
the
see some
lantern?
UFOs on Twitter afterwards?
They got to be going to bed soon. We're gonna make some UFOs flying around. Say bye-bye.
Bye-bye. Bye-bye. Bye-bye.
We're gonna go eat tacos. And go to
Bye-bye.
bed.
Bye-bye me.
Oh, guest 314 just posted a copy of the website. Good night, Nico.
I gotta go. I'll see you guys later.
Bye.
What'd you have?
I'll see you later.
Come on, let's go.
Oh, nice.
So Chuck Wade is basically a guy involved with the Roswell incident.
Yes. Actually, no, he used to live there.
But he's claiming these samples are from Roswell, right?
Yes, that's correct. He says that there were many crashes, not just the Roswell. And one of those crashes, that's where he picked up those pieces from.
That's amazing. I mean, the most important thing that I found from that is that the ratio of iron to aluminum is much higher than I previously thought. And that's something I'm definitely going to be looking into in our next experiments. 10% is a lot higher than David suggested. It needs to be like 0.5%.
Actually, it's on the Alzofon experiment. I just found where I saw the info. It's on page 5.
You want to do a share screen?
Oh, okay. Yeah, sure. I'll share screen. You see that?
No.
It's right here. It says 1 to 10. Ratio of iron nuclide to aluminum nuclide is 1 gram per specimen. Should be about 1 to 10.
What?
Well, that's what the Alzofon experiment says, the report. Look at this. This is the Alzofon.
I don't see your share screen.
Oh,
Yeah, it's the share screen.
hold on then. I thought you were looking at my share screen.
I have the paper right here. Let me pull it up.
Okay.
Pull it out. You're saying on page 5.
Now that you see my screen,
Yeah.
right here, it says 1 to 10.
Oh, yeah, I must have missed that because I think David told me it was supposed to be about 0.5%, but that is exactly what they saw in Wade's sample. Oh, fuck. That's probably what was missing.
Well, that's another way to.
I mean, the issue with that much iron in it is, of course, If you have that much iron in the metal, it will attract to the magnet. So having the magnet horizontal like we have it right now is good because it can't create weight loss or weight gain by having it attract. So we'll get accurate measurements hopefully.
Well, actually, Alzofon mentions that. He says the optimum quantity of iron to be embedded in the aluminum must be determined by the experiment. So if it's attracted, we have to reduce the amount of iron. It's right on top.
Yeah, I tried that. I made aluminum. You know what? I think I need to try that again.
Okay, I'm going to stop sharing, okay?
Yeah, I need to try that again. Make some more samples using that description. I think I need to do that.
Okay. Well, I gotta go, okay? Anyway,
Okay,
thank you very much and have a great night, guys.
me too. I'm gonna end this right now. Unless
Okay,
anyone else, anything else to add?
all right, bye.
Good night, everyone.